This should produce two confidence intervals, one for males and one for females. Okay, so what we'll do is, once again, we've defined our main variable of interest, current salary. We can put any continuous variable in here, any scaled variable. And our category is gender. Okay, so, and we've already defined it as confidence interval for the mean at the 95% level. So let's hit OK. What we get out is we get two confidence intervals. Okay. Now, once again, just the interpretation here is that the round circle represents the mean. So in relation to the female distribution, okay, the mean is positioned here, which is just slightly above €25,000. $25,000. The confidence interval lower bound is at $25,000 and the upper bound seems to be about $27,000. So what we can actually see is, with respect to the mean, the confidence interval is very tight around the mean, which would suggest to us that, well, compared to the male distribution, okay, you can see that the confidence interval is a lot wider. Okay, but I mean, in both cases, this interval with the upper bound and the lower bound would give us an upper bound and lower bound of where we would believe the true population mean for males would reside. So what we're saying is a true population mean for males would typically be between just under $40,000 and just under $45,000, and we'd be 95% confident about that particular claim. Okay, let's continue. Let's go to graphs, legacy dialogues, error bars. There's other options that we can choose. We could create intervals that are based off standard deviations. Okay, so let's just choose standard deviations as an example. The multiplier here allows us to choose the interval based on a certain number of standard deviations, plus or minus. Let's just choose one. So one standard deviation above and below the mean value. Okay, so once we do that, what we actually get is we get error bars that look something like this. Once again, in the female situation, you can see that one standard deviation above and below is quite small relative to the male distribution of one standard deviation above and one standard deviation below the mean. What this would suggest to us is that the female distribution is quite slender, okay, compared to the male distribution, which is quite broader. Okay, but the interpretation is the same. The male distribution, the average seems to be in around $40,000. One standard deviation below seems to be in around $21,000, $22,000, and one standard deviation above seems to be in around about $61,000. Okay. With respect to the female distribution, one standard deviation below the mean seems to be just below $20,000, and one standard deviation above the mean seems to be between $30,000 and $40,000. Okay. Actually, let me just roll back up here for a moment, to the confidence interval calculation. Now, we're not talking about hypothesis testing here and tests of difference, but an alternative way to actually find out whether there's a significant difference between groups associated with a dependent variable, okay, is to look at the confidence intervals. If the confidence intervals overlap, that would suggest that there's no difference between them, or there's little evidence to suggest that they're different. If the confidence intervals don't overlap, that would be evidence to suggest that the actual means of these particular populations that the samples have been drawn from are actually different to each other. So we can actually see in this particular case here that there would be evidence to suggest that the average salary of females is in fact less than the average salary of males. Now, if we undertook a hypothesis test, either an independent samples t-test or a Mann-Whitney test, depending on the shapes of the distributions, then the results of them particular hypothesis tests should also, I suppose, support what we're seeing here from a graphical perspective. Yes. Okay. So the final type of interval that we can do through error bars is looking at the standard error of the mean. Okay. So once again, we go back to simple, define. Instead of standard deviation, we'll choose the standard error of the mean. Okay. And let's hit OK. And in this case here, the standard error of the mean is got to do with the sampling distribution. It's actually the standard deviation of the sampling distribution. The smaller the standard error, yes, the less the mean, the more not necessarily the more confident we are in respect to the mean value, yeah, but the less error that we've observed in relation to the samples that we have drawn from the population. You can actually see that the standard error of the mean, or the standard deviation of the sampling distribution for females, is actually quite slender or quite small compared to that of males. Okay. So, guys, that was 3 examples of how to do error bars through IBM SPSS Statistics. Just once again, what we looked at was a typical 95% confidence interval error bars. We looked at, I suppose, looking at 1 standard deviation above and below the mean. We could go for 2 or 3 standard deviations, depending on what you want. And we also looked at the plot of the standard errors associated with the standard error of the mean. Okay? The variable doesn't have to be gender. The independent variable can be anything at all. Okay? But in this case, we just chose gender. It would be the same process for another particular type of independent variable. Okay, guys, once again, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope this was somewhat helpful.